Okay, so last week, we saw how to do the Kubernetes cluster deployment, and then we also, saw this Kubernetes architecture, and then we saw how to create pods, services, replication controller, and replica set. So this week, I wanted to show you how to integrate Kubernetes with Ceph. Okay, that also I wanted to show you today, like this week, apart from various other objects like deployments, labels, health checks, secrets, config maps, empty directory, persistent volume claims, and role-based access control objects like cluster cluster role binding, and role binding, service accounts. Okay, these are all so there are plenty of things that I want to cover. So first, I will do the deployment again for you because like I need to provide you one Google Cloud image, right, to in a ready-made Google Cloud image so that you can practice. So let me just create one deployment again for you, and then we also need to deploy Ceph. We will be, okay. So we won't be using Ceph Ansible. Instead, we will be using Ceph deploy. Okay, because we need to deploy the latest version of Ceph, that is Mimic. In case of OpenStack, we were using Luminous because OpenStack was integrated with Luminous, not with Mimic. Okay, in case of Rocky release, so we were using Luminous and we deployed using Ceph Ansible. But here we'll be actually using Ceph deploy, and we will do the deployment of Mimic release. So let me go to the Google Cloud. Second.
Mimic release, you're talking about mimic release of Ceph, is it?
Sorry, Pradeep, your voice is bit.
Mimic what you are telling? Mimic is release of what?
Ceph release.
Okay,
Ceph,
okay,
Ceph.
okay.
Do you remember we were exploring Luminous release in the during OpenStack? Now we will be exploring Mimic release.
Okay. In our class also we have done this by self deploy only in OpenStack also.
Oh, is it? Okay, 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 okay.
Yeah, we have not used Ansible.
Oh, maybe for the other batches. Okay, maybe the January batch we did it using Ceph Ansible.
Yeah, maybe.
Wait, some issue. Let me just fix it. Okay, it's ready. Fine. So let's set up the environment. We'll create a Kubernetes lab. We'll be creating 3 Ceph machines and couple of Kubernetes machines. Maybe we can create 3 Kubernetes machines also. So maybe we will take this 8 CPU and 30 GB RAM. This should be enough. And with respect to disk, okay, anyway, that is, let's take Ratan trainers. We will take hypervisor password image. 50 GB size is enough for us. Okay, so for Kubernetes we will use Ubuntu. For Ceph we will use CentOS. Okay, so let's start the VNC. There you go. So go to System Tools, Virtual Machine Manager. So here first I will open the Ubuntu machine. We will do an apt update. And also apt upgrade. Okay. Next, we will do the update of CentOS. Is CentOS release 6, release 8 done? When is it coming out? Oh, still not yet released. And what is the kernel? Wow, it is going to use 4.18. That's nice. Quite a big jump. First, we will kickstart the Ceph installation. While the Ceph installation is progressing, we will do the Kubernetes installation. We will have one master node and two worker nodes for Kubernetes. And when we look into OpenShift, I will show you how to set up three master nodes and three etc DE nodes. Like we will do just like the OpenStack HA. We will do here also with 11 servers. We will do the Kubernetes deployment in HA configuration. We will try to do it with OpenShift. Okay, while this goes on, we will clone this Ubuntu machine for Kubernetes. Kube master. Okay, this cube master, we need to provide two CPUs. Okay, we already have two CPUs, and memory, it has to be 4 GB is enough, but we will provide 5 GB. And next, we will do another clone. This time it will be cube worker 1. So this one, this is okay. We'll clone it again to create the second worker. So Kubernetes is a cluster of 3 machines. Next we will clone CentOS. Hopefully the update is done. Okay, let's power off. So let's clone Ceph1, Ceph2, Ceph3. 3 machines we will create. So Ceph1, and to the Ceph1 we will add few extra disks for Ceph OSDs. Okay. What happened is not having enough free space. What? Okay, let me check how much space is available. df minus h, we have 20 GB available. Okay, var libvirt d images qmo img create minus f qcow2 ceph1 volume 1 dot qcow2. This can be 20G. Similarly, volume 2 and volume 3. Next, the same thing for Ceph2 machine. Not required. Anyway, we are going to clone it. So existing disk, refresh, finish. Another disk. Okay, we have added 3 extra disks.
Rajan, why we did this Qmo IMG to add the disk? We can have directly also we could have added the disk, right? 20 GB.
When we add the disk using Word Manager, it will be checking how much free space is available. So here, if you check the free space, it is less than like it's okay. If you just do df enter, you can see that it is having a lesser space, like less than 20 GB. So it is not allowing me to create a 20 GB volume. So
Okay,
that's
that's why
why
you created the virtual disk.
uh, yeah. So the Word Manager also creates the virtual disk, but it does this check. Okay. So to bypass that check, I directly went and then I did this qmo img. I used this qmg create command to create the disk. So this doesn't do that check. Only the Word Manager does that check. Is it clear?
Understood, understood.
Okay.
In previous classes, we have done it directly. We have not then used the QMO
Yeah,
IMG
because
part of
we were
it.
using 100 GB disks previously, but this one is
Right,
a
right.
50 GB disk.
Right, right.
So I'm keeping the disks to the lower side to,
Yeah.
you know. So let me create. Okay, I need to rename this. It has to be safe 2. Can I change the disk name? No. Okay. Next, safe 3. Cool then. So now let's check. We are a switch list -fn all. So we have 3 Kubernetes machines and 3 Ceph machines. Okay, we will assign the IPs for these 3 and then we will set up the cluster. Uh, okay, I don't need this ISO. Let me also check the downloads directory. Does it have anything? Here also we have one ISO. Now if we do df -h, we must have more space. Still we have only 19G. But 19G free space is more than enough. But still, I'll just try to do a cleanup. Okay, while this calculates the disk utilization, we will start assigning the IP address. Let's start the Ceph1 machine. The standard IP, we need to replace the standard IP with some other IP. Okay, so here user 3, so it is mostly var. If you go to var, disk users -sh, it must be our libvirt. See, lib, there you go. So it is images directory. So Ubuntu, this one uses a lot of memory. Kubernetes doesn't use. Okay, this is this much. This is not required. We can remove this. This is also not required. It's all fine, and these are all fine. Why this one is? Why this is 4 GB? I don't know. The actual parent is only 3 GB. Crazy. Okay, fine. Anyway, if it's required, we will do the disk cleanup. So this is Ceph1 machine. and let's set the IP address. So instead of 4, we will call it as, this is safe 41, I will say. Then just do the reboot. Next we will start safe2 machine. Okay, it started. Let's log in. safe2.example.com. So this we will set it to 42. Reboot. Next we will start safe3 machine. Okay. .43. So we must be having 3 machines. Safe. Cool then. So we have all the 3 machines ready. Okay, so let's power it off. And we will create, we will assign the IP for the Kubernetes machines also. So we are at a start, kube master, ping, call this as kubemaster.example.com. Remove this entry. So here IP we will give it as 115. Reboot. Next we will start the worker node. 116. Next we will start worker 2 machine. This one will give 117. I'm not going to populate the etc hosts. Instead, I will populate all the entries in the etc host of the hypervisor, and then we will start restart the KVM and its DNS, so that it will pick the DNS entries directly from the hypervisor. So that way we avoid a work of configuring etc hosts on all the nodes. Now let's do the reboot and ping 10.0.0.11 5 6 7. Let's wait for the 7th one to come up. Okay, they're all up. Let's try to log in. Cool then. Host name. Okay, everything is fine. Power off. We have all the machines ready. I don't have the scripts to create the snapshots. Let me get it from my local server. Start all, snapshot, shutdown, revert, list, delete. Right click, download, temp. Okay, now close this. We will upload it to this machine. Upload. Okay, I have the scripts here. I need to create only one extra script, that is notes.txt, because all the script uses this. Here I need to check sef1, sef2, sef3, cube master, cube worker1, cube worker2. These are the VMs. Let me just do list snapshots. Oh, okay, I need to put execute permission for these shell scripts. List snapshots. There you go. Okay, now let's create the, okay, first let's check whether all the VMs are not running. Snapshot, you can say ready, or you can say OS ready. That's it. Now let's start all the VMs. Cool. Okay, first let's do the Kubernetes installation. I think that is better. Second. Okay, so let's log into all the three Kubernetes machines. Okay, first before that I need to set up the DNS. I totally forgot that. Let me shut down the machines. See, since the DNS is not set up, it is failing. Okay, so etc hosts. So here I need to add 10.0.0.41 safe1 safe1.example.com. 42, 43. Next 10.0.0.115 kubemaster.example.com. Can also say kubemaster.
So here we are using the Ceph as a background storage for volumes.
Exactly.
Okay.
So we'll be integrating Ceph with Kubernetes. Just like we did it for OpenStack, we'll be doing it for Kubernetes. That's it. Now I need to stop libvirt. It's not loaded. Oh, sorry, spelling mistake. Then check whether we have DNS running. Generally, it will be running. Let me kill the all the DNS MosQ processes, and we will restart libvirt d. Now, if you check, the DNS will be running. Cool. Now we are a search list.
So what we did here, I mean, we stopped libvirt and then kill all DNS by doing what we are doing.
Okay, so basically what we did is, see, we have populated the IP address and the host name details into the etc hosts file of the hypervisor. Okay, this hypervisor, that is libvirt, if you just check systemctl status libvirt, okay, so this is the KVM. This internally has a DNS. Here you can see the DNS processes running, which refers to etc hosts. So, okay, so whenever we make any changes to the etc hosts, if we want the DNS to pick the changes, we need to restart the DNS. So for that, we need to restart the libvirt so that the DNS picks up these changes that we have made on etc hosts. Okay, that's why we stopped the libvirt. But when we stopped the libvirt, it was not stopping the DNS. So I killed the DNS processes, and then I restarted the libvirt, which started the libvirt and as well as DNS child processes. Is it clear?
If we just, I mean, restart DNS MosQ process, whether that will not do?
This DNS MosQ process is not directly managed as a service. It is a child process of libvirt. You can see here. Okay,
Okay.
so the libvirt starts internally the DNS MosQ. We are not running it as a separate service.
Okay, DNS MosQ itself is not a separate process, is it?
Yes, it is a separate process, but part of libvirt service.
Okay.
See here, the libvirt service instantiates libvirt DNS MosQ. Okay. So now let's log into the three VMs. And here, if we just try to ping Kubernetes 1, oh, it says unknown host. Okay, let me just do, okay, why it's saying unknown host? Cat etc hosts, sorry, cat etc resolve.conf. It is pointing to 10.0.0.1. Let me do a reboot and check. It must, okay, it must be able to, get it. It is part of. Oh, I said Kubernetes one, right? There is no Kubernetes one. Oh, stupid me. It is Kube Master. Okay, that is my mistake. I was speaking. Okay, what was the IP that I was speaking? I was speaking Kubernetes 1. Okay, that is the name that I'm using in my lab. Okay, I should have pinged a kube master. I'm very sorry. Ping kube master. You can see it automatically picks the IP. This is getting it from the DNS. Similarly, you can also check kube worker 1. You can give either worker 1 or worker1 at example.com. Both will work. See? Okay. Now, let me shut down. Okay, shutdown is working. Snapshot is working. Let me start all the missions now. Okay, SSH. There you go. So we have the missions. Okay, so I will prepare the mop simultaneously and then I will share the mop with you. So the first step is we need to prepare the nodes for Kubernetes installation. So these steps are common for all the 3 Kubernetes nodes. So that's why we are in kubemaster, worker node and worker node 2. The promptless login is already set up between these machines. You can check here, kubemaster hostname. There you go. See, it is able to contact. Similarly, you can also check kube worker 1. It works. Check kube worker 2. It works. Cool. Fine. So the first thing is we need to just do yum update at the rate of apt upgrade -y to check everything is fine.
Sir, you have uploaded around 9 document in Google OneDrive.
Yes.
Right. So which for the first class, which document we should refer? There is a replication controller deployment.
Yes. For the first we touched replication controller and replica set and service and pod. So you can refer first to 2 or 3 documents.
Okay. So architecture PPT is also there in the document.
Okay, I will actually upload it separately. I think I didn't upload that. I will upload it today. it taking so long? Oh, okay, it was already done. My God, okay. I should have used the double end. Okay, now it's fine. Okay, next we need to install Docker on all the three machines. So I have to install Docker IO. This will install the Docker from Kubernetes repository. Next, we need to set up the repository for Kubernetes. So let's open apt sources list, Kubernetes list file. So the apt under etc apt source list.d subdirectory. Inside that, we will create a new file, kubernetes.list. Here we can provide the repository details. So this is how we have to do it in Ubuntu. Deb, this is the URL. Inside this URL, there will be a distribution, that is Kubernetes Genial. Genial is the code name for Kubernetes 16.04, and main is a subdirectory within that. We can verify it by just going here. Just go to that location. Here you will see the distribution. So inside the distribution, you will see Ubuntu Genial. You can check, okay, Ubuntu Genial. Sorry, Kubernetes Genial, right? Okay, here it is, Kubernetes Genial. There, under that, the main folder which has the packages. So if you just do cube minus A, cube minus A, why is it not showing? Okay, maybe cat etc lsb release. Here you can see Ubuntu 16.04, the code name is Genial. Okay, so next let's also add the apt key. This is like a GPG key in case of yum, which will authenticate the packages. Next, do a apt update to update the repo that we have just added. You must be able to see the Kubernetes Genial repo. See, it's there. Now we need to install kubeadm, kubelet, and kubectl packages. So kubeadm is the CLI for all Kubernetes administration purposes. Kubelet is used for all the other purposes. So this kubelet is the package, that manages the, what to say, the one that interacts with the Docker and manages all the Kubernetes objects on Docker. Kubectl is the CLI. Next, we need to disable the swap. So if you just check cat proc swaps, you will see swap is enabled. You can also do free minus h to see whether the swap is enabled. We need to disable the swap. So to disable the swap, just say swap off minus a. Now if you do minus free minus h, you can see swap is 0. You can also try that cat proc swaps. You must not get any entry. To make this permanent, go to etc fs tab. There, the swap entry, you comment it out so that the swap is not reloaded. Okay, so once it is done, then let's shut down and take a snapshot before we proceed further. I just say shut down all. Ready for Kubernetes. Start the missions. SSH into these missions once they are ready. So next we need to deploy the master node, and then we will deploy the worker node. So for that, the master node, we need to first download the Calico YAML files from the Calico project site. So this Calico is going to be the network plugin for our Kubernetes environment. So here we have downloaded two YAML files. One is the role-based access control. Okay, we can check this. So here you can see, so it actually creates a cluster role. I will talk about this cluster role and role binding, cluster role binding later. And first I wanted to touch some objects like deployment, secret, config map, empty directory, all those things. Then I will talk about these aspects. So for now we can just copy and paste and proceed further, because this API groups, resources, everything has a special meaning. This is the role binding. Next we can check the Calico. So here they have the config map, service. So the Calico runs as a service. Deployment. For distribution budget. This is daemon set. Daemon set means the instance, there will be one pod running on all the Kubernetes nodes. What else they have? Service account, custom resource definition. Okay, some few custom resource definitions. Okay, that's it. Okay. Anyway, you don't have to understand this. I was just like going through to check what it has. Now we need to check what is the default pod IP CADR used by Calico YAML file. So this is the IP that we need to use while setting up the master. So now let's say kube admin init Kubernetes version 1.13.1 pod network, this network, and just we will save the output in kubeadm int.out. What does it say? Kube version is higher than the control plan version. Kube led version, okay, this is not supported version SKU. So kubelet version is 1.104. The control plane is 1.3. Okay, it's asking us to use 1.14. Okay, because we have installed 1.14 kubelet. So let's install 14.0.
kubeadm is installed with which packages?
Remember, okay, let me just show you here. If you just do apt, see, we installed apt install kubeadm, kubelet, and kubectl. We installed it separately.
Okay, kubeadm is the command line utility, and kubelet and kubectl is the other component of the Kubernetes, right?
No, kubeadm and kubectl both are command line utility. kubeadm is used for managing the cluster. kubectl is used to work with the various resources of Kubernetes. Kubelet is actually a service.
Okay, I think kubelet is to monitor the pod health or container health.
No,
Is it?
kubelet is actually the service that will be interacting with the container engine to create the pods. The monitoring of the pods is done by the controller manager. Basically, the controller manager is where it will be running the controller services like replica set, replication controller, etc. So those will be, monitoring the pods through through kubelet, and if the pods die, they will, auto heal those pods. Is it clear? Anyway, I will actually show you once this master node is done. I will show you the those processes running. So now let's press enter. So here we are initializing the master node, and the Kubernetes version is 1.1.4 pod network, and the output we will save it here for future reference. While this goes on, let me check the memory utilization. Oh, we have 21 GB free. Good. CPU It's also close more than 95% free. Nice, not much overloaded. So we can parallelly, while the installation is going on, let's log into Cube Master, check what are the processes that are running. Here you can see the controller manager, which actually manages all the controlling objects. Controller objects like replica set, replication controller, and deployment are all managed by Cube Controller Manager. Here we have the scheduler and API server, kubelet, kube proxy, etcd, all are started. So the installation is almost done. Waiting for the kubelet to boot up the control plane as static parts from directory etc Kubernetes manifests. So here you can see the controller manager pod and the kube scheduler pod, etcd pod, API server pod, all running. Okay, why is it taking so long to complete? It has been more than 4 minutes, right?
I think CK exam is based on the it's a hands-on exam, right?
One second. Yes, Sujit, you were asking something? Sujit?
Yeah, I was asking CK is based on the practical, right? It's
Yes,
a
yes,
hands-on exam, right?
yes.
And Docker is not the hands-on, and there is a multi-choice
That is a
question.
multi-choice. That is multi-choice. Yes.
So if I have exam voucher, so I can write the exam once, or I can, or it is
There is a free retake.
for CKA or Docker, or both.
No, not for Docker. It's only for CKA and for OpenStack. For these two only, there is a free retake. Any exam conducted by Linux Foundation, there will be a free retake.
Okay.
It's asking us to check the journal CTL. See, unable to update CNA config. No networks found. No network found. CNA netd. Container until network not ready. This is an issue. So this is the problem with using the latest versions. We used to get some one kind of the error or could not initialize. Okay. What is the solution? Come out of this. Okay. So it's stuck here. No networks found in etcd. Let me just quickly check the Kubernetes document. This is a new error. Maybe they might have changed their document. So we have installed these packages. Okay, this is fine. So we have two CPUs and 5 GB of RAM. So we did kubeadm init, then we gave the pod CADR, installing a pod network add-on. Okay, and then so we gave this, and version also we gave. What else is required? And it's taking more time than mistake. Calico. So this we need to do after the installation of Kubernetes. Okay. Let me do one thing. Press Control C, Cube, ADM. Reset. Okay, now we have reset it. Let me do install, remove. I will try to install 1.1.3. See whether it works. Oh my God. They have updated the repo, but the installation is not going through. Last week the installation was going through, but internally there was some issue we faced. But this week we are facing this issue. So release main. How do we use a specific version in the repo? Okay, so here they do only this. They are not able to. Okay, there is no way to specify the version here, and here in the main. So here check for cube ADM. One dot 13. They do okay. They have 1.13.1. It is available for cube ADM. It is available. Okay, so where are we facing this issue? Install. The version is available. Hmm. Let me just do the installation of this around first. So the problem is with the Kubernetes CNI. So the Kubernetes CNI package colon Kubernetes CNI. What version it requires? It requires 0.6.0. It does have, okay, so we need to specify that separately. Kubernetes CNI. Okay. Luckily the versions are available. Now what? Kubelet. Okay, so let's also provide the kubelet. So package kubelet. So we want 1.13. My God. Okay. All the versions are there. No problem. Okay. We want 1.13.10. This is the version that we are focusing on now. Just get this kubelet. Similarly, kubectl. Install it now. What? Okay. I need to. The best way is. Let me just do one thing. Okay. I need to say allow downgrades. Fine. Okay, it's installed. Now let's try it again. This time it should go through. Okay, this is where we got stuck last time. Let's check whether we are going through this stage now.
So this is the only way to install the Kubernetes cluster, or is there any other
There are
way?
plenty of ways.
Okay, so generally in production environment, do we use any automation tool to deploy the Kubernetes cluster?
Uh, See, it depends upon what kind of. See, now it got installed. Fantastic. Okay, see, if you just check, let me just show you that document which shows plenty of ways to deploy Kubernetes. Kubernetes. There are automation tools available. Even OpenShift is also one of the tools for deploying Kubernetes platform. Come on. So here, just go to setup Kubernetes, and here you can see now these are all on the public cloud, on premises. Okay. Turnkey on-premises solutions. Okay, there you go. So here you can see the OpenShift is one platform. Like that, you have Rancher, and like that, this Docker Enterprise that we have installed that also has the Kubernetes support. So like that, the Mirantis Cloud Platform. So many things are there. So these are all automated solutions. We'll be seeing how to do this OpenShift deployment in a couple of weeks. So generally, in most of the the data centers who use Red Hat solutions, they generally prefer OpenShift. Okay, so now we have deployed the master node. So let's just copy this to a notepad. So the problem was with the 1.14 release. Okay, with 1.13 it went smooth. So now what we need to do is we need to create a non-admin user, like non-root user with the sudo privileges, and then we need to set up the kube configuration for accessing the Kubernetes platform. Okay, so let's see how to do that. So here in the master node, let's add a new user. Add user. I will just call it as student. Call it as Rajan. Okay, I will give the username Rajan123. Rajan123. Then full name. Information correct, yes. So here we have created. I will just log into Rajan. So here you see we are able to log in. Good. So next we need to, so after we add this user, so next is we need to provide sudo privileges for this user. Okay. So we need to say user mod -ag sudo Rajan. Okay, this will add the user Rajan to the sudo group. Now let's log in as Rajan. Then we'll say sudo apt update. This should not, this should ask for password. Give your Rajan123 password. See, now it is working. So it means the sudo privilege has been provided. Okay, there are some packages to be updated, but it's okay. apt list upgradable. Those are all here. It wants to upgrade from 1.13.1 to 1.14. Now we just had a problem. We don't want this. So just keep it as it is. So next, if you just check, the first thing is we need to create one .cube directory. So ls minus l la. So here we need to create a cube directory. There you go. So next we need to copy the etc kubernetes admin conf file into this config directory, which will have necessary access privileges, instructions like the context key, everything will be here. We just open this. We need to provide the permission. So change the ownership to this current user. Now you must be able to wait bash rc. No. va.bash profile ls minus la. Do we have? Okay, it is dot profile. Okay. Set minus vi. There you go. So here you can see the cluster details. The clusters. So this is the location where the API is listening on. Then the certification details and the contexts like the user, etc. And then the configuration details, the admin user credentials, all are specified here. So only if it is available, we'll be able to run the kubectl command. So next we need to apply the network plugin configurations to the cluster. So remember the files that we have copied, that we have downloaded. So let's just copy that. So sudo copy root rbackdd YAML, and copied it. Now you can just say kubectl apply -f. That's it. This will create the cluster role and the cluster role binding. Similarly, sudo copy root calico .yaml apply -f calico YAML. Okay, so once it is done, then if you do kubectl get nodes, you must be able to see. Okay, the node is still not ready. Okay, kubectl get all. See, it's working. Get all -n cube system. There you go. So what is it creating now? Calico. Okay, it's creating the core DNS pods. So that's why. Okay, now everything is running. If we do kubectl get nodes, status is ready. Fantastic. Now we have deployed it. So when you do this kubectl get, and if you press double tab, it must list the various objects of Kubernetes, but it is not doing that. So if we have to do that, we need to enable the BOSS completion. So there is, if you just do kubectl completion bash, okay, this will give you a big shell script. Just check here. This is a big shell, shell script. It is close to 8,000 lines of code. Okay, so you need to just source this, which will provide you the BOSS completion feature. Now if you do kubectl get, and here if you press double tab, so you see it lists all the resources like secrets, services, pods, and where is our replication controllers, replica sets, everything is there. Okay, but previously when we did it, it was just showing only the current directories files. So this BOSS completion is a very nice feature which saves a lot of our time. So this you need to do it every time when you log into this Rajan directory. Instead you can also put it as part of the this BOSS archive file. Just go to bash rc file. There at the end you can put it. So that way you don't have to source it every time. Whenever you log in, it will be automatically sourced. Let's log out and try to log in now. And then now if you see kubectl get double tab, see it is showing all the values. So now if you just do PO tab, see it actually auto completes pods. That's it. You can also do -n cube. See, it auto completes. In case of Docker, this BOS completion is by default enabled, but here we need to like enable it during the installation. Okay. So
So
now
these are the pods which is created by default.
yes, these are all the infrastructure pods, the pods of Kubernetes, like the Kubernetes API server, controller manager, proxy, scheduler, and etcd. They are all running as pods. These are all called as infrastructure pods. So the
And the kube system is the cluster name.
Sorry?
Kube system is the cluster name. Is it?
Cube?
Kube system and kube hyphen system.
Oh,
the
this is the
name.
no. This is the namespace. If you just do kubectl get namespaces, you can see kube system, default, kube public. These are all the default namespaces. All the infrastructure pods will be running in kube system namespace. Got it?
Okay, sir.
Now let's just shut down all the VMs and take a snapshot before we proceed further. Next, we need to deploy the worker nodes. So take the snapshot. Okay, now we will start the nodes. Okay, so let's log in. So now we need to join this worker 1 and worker 2 as part of the cluster. So okay, let's just go to the Rajan user. So here if we do kubectl get, first we need to check whether all the processes are up. Grep cube less -s. No, still they are not up. Let's wait for the processes to come up. This kubelet will immediately start, but the kube's API server, scheduler, controller manager, etcd, those will take some time. So since this is a VM running on a VM, it may, okay, see, now it is coming up. API server, control manager, both are up. Scheduler is up. etcd is up. Okay, almost everything is up. So now let's go to Rajan user. Now if you do kubectl get nodes, okay, you must see the node in ready state. So next okay, so if you have say, okay, so if you just do cube C, cube ADM, to manage the cluster we use cube ADM. Cube ADM token list, you must be able to see the token that is available. We can use this token. If you don't have the token, you can always create a new token. Okay, so this is the, okay, if you have this string, you can use this string to join the node. Okay, if you don't have the string, then we can build the string from scratch. Suppose, say, assume that you don't have this, so this token will be valid only for approximately 24 hours. Okay, suppose, say, you created the master node, and then after 24 hours you decided to add a worker node. First you need to create a new token. Cube ADM token create. This will create a new token. This is the token ID. So just save this. You can also get it by just doing cube ADM token list. So here you can see the same token can be got from here also. Both are one and the same. So this is the token. So copy this token here, keep it safe. So we need to actually use this format, cube ADM join. Okay, provide this and provide the token. So next we need to say discovery token hash, and we need to give this SHA-256 key. So this can be got from the certificate of Kubernetes. So for that, so the certificate is available in etc kubernetes pki directory. You will say ca.crt. From there you can create the you can get that SHA-256 hexadecimal code. So for that you need to use OpenSSL x509 hyphen pub key hyphen I. So we are reading the pub key from the certificate. Then open SSL RSA pub in out form dir. Then pipe it to OpenSSL digest SHA-256 hyphen hex. This will give us the number. Okay, so just take this number and put it here. You can see this number is same as the previous number. So this is the process to generate that number. If you have saved this join key before, you can use that directly. Otherwise, you can build this same string like this. Now we need to go to the respective machines and run the join command. What happened? Okay, so here also we have this 1.14 version. That is the problem. Okay, so kubectl, no, we have to say apt remove, wait, first install, need to say remove. Here also we will remove. We have that 14 release. We must also remove that what is that other package? Kubernetes CNI. Okay, so now let's install those packages again. That is 1.13.1 packages. Here too we will install. So this Kubernetes has a very short release cycle. So always use one release older, so that it is little bit stable. If you use latest release, generally it is not that stable. Sometimes it works, sometimes it doesn't work. Now what? Okay, cube ADM reset. Okay, try it again. Yeah, it works. Okay, now if you do kubectl get nodes, you must be able to see one worker node.
So what is KubeADM reset does actually?
Okay, suppose say if you have joined a node, okay, and later if you want to reset, okay, if you want to revert that join operation, you can do kubectl reset. That will just remove that, it just reset the node to the previous state. So whenever whenever you run kubectl init or kubectl join, if you want to reset it back to the, or basically you want to remove it from the cluster, you can use kubectl reset. Now let's join this node also. Now let's do get nodes. Okay, see, worker node 1 is ready. We'll wait for the 2 node also to be ready. Then we will take a snapshot. Then we can go ahead and proceed with the installation of Ceph. Now let's check it again. There you go. Okay. So let's take a snapshot. So here we have the plain operating system. Then we prepared the Kubernetes. Then we did the master node deployment and worker nodes we added. Okay. So start all. Now we will do the Ceph deployment. We'll wait for the nodes to come up. Okay, there you go. So let's log into the Ceph. Okay. So first thing we will disable firewall and also network manager. Stop. Check whether they are inactive. Okay, so once it is done, next we need to set up the NTP. I don't know whether the NTP is set. Let's just check. Cron EC sources. Okay, by default NTP is set up, no problem. So let's check whether the time is synchronized. Okay, so here you can see the time difference. It is less than 9 milliseconds, or 10 milliseconds. So these two nodes are perfectly synchronized. This one is 9 milliseconds ahead. It's okay. It can The time difference can be max 50 milliseconds. If it's going beyond milliseconds, then safe will complain. Here it's not a problem. So the time difference is perfect. Okay. So now we need to set up the safe. So for safe, since we have some new students like Amadou who haven't worked on safe before, I will use the safe installation guide. So just go to safe installation. It will take you to the safe.com install page. So there, if you just come down, you will see safe in a installation quick. Click on that and select RHEL CentOS. There you go. So the first step is we need to install the Apple release package. So let's do that. We can install it in one server, that is enough. Just on CentOS, this F1 alone we will install. If required, we will do it on other machines. Generally, this should be enough. So once it is done, next we need to set up the safe repository. Just copy this. Anyway, I'm also preparing you the mob, so that should be okay. etc m.repos.d safe.repo. So here you copy this, and the release you need to put it as mimic. So now we need to just do yum update and do the yum install safe deploy. So first let's do yum update -y. Okay, then next we can do yum install safe deploy. The safe deploy is the tool, okay, to do the deployment of safe. So after we use the safe deploy, next we need to run the safe deploy install command to install the actual safe packages. So now the version you can see it is 2.0.1. This is the version for Mimic. Okay, so once it is done, then just come down. There will be too much blah blah. Okay, I will just give you only the required essence. Next, we need to create a cluster directory. I will actually put it under etc safe directory. Go to etc safe. So here we need to create the keyring files. So for that there is safe deploy new command. So just provide that, and you need to give the monitor device name. Safe has three monitors and OSDs and MDS and RGW and managers. There are various components are there. We cover all these things in detail as part of our OpenStack program. You will face this error. Okay, so we need to install this Python setup tools package. So just to do yum search Python grep setup. There you will see the setup tools package. Just install this. Yum install Python setup tools. Then we will try to run the previous command, deploy new Ceph1. See, now it succeeds. So once it is done, if you just do ls -l, you'll be able to see the monitor keyring file and also Ceph configuration file. So, here to the Ceph configuration file, we can add the public network. So this is the network that will be used for the communication between the client and the Ceph OSDs and Ceph monitors, etc. If we don't provide the cluster network, the same public network will be used for internal cluster communication also. Okay, so now once it is done, then we can initiate the installation. So Ceph deploy install, Ceph1, Ceph2, Ceph3. So this will do the installation of Ceph on all the three machines. So this is what actually downloads the Ceph packages and does the installation. So just press enter, sit back and relax. This will do the installation. Generally it will take 10 minutes. Maybe we can take a break during this time. Let this installation go on. Let's take a break for 10 to 15 minutes. Oh wait, there is an issue. Let me run this. Okay, if you face this, just run it again. Generally it goes through. See, now it went through. Okay, so we can take a break. Actually, that error happens because we already have ceph.repo, right? So when the ceph deploy tries to create another repo file, okay, so there is a conflict. That's why it throws that error, allowing us to resolve the conflict. If we just run it again, it will just go through. Okay, fine. So let's take a break for 10 to 15 minutes. And once we are back, we will have the Ceph install. We can set up the Ceph repo, the Ceph pools, and we can go ahead with the integration of Ceph with Kubernetes. So let's take a break for 15 minutes. Are you all back? Okay. So now we have installed safe. So now if you just go to multi-exec mode and do safe -fn version, you must be able to see the mimic version here on all the three missions. Okay. So once this installation is done, the next step is we need to set up the monitor. So check here. Once the installation is done, next is we need to initialize the monitors. So just copy this and run this command only on safe 1 machine. This will initialize the monitor. So we require at least one monitor to be running on a safe cluster. Monitor is the one that does, manages the crash map. So it's done. Once it is done, then if you do safe -s, you must be able to see this output. And here in this output, you can check that it has the health is okay, and it has one monitor daemon that is running on safe 1 machine. No managers or no OSDs are running or deployed it. So let's deploy. Okay, so if we want to copy this admin, so this also creates an admin user. If you just check, you will see this admin user keyring file and all it has been created. Okay, this is done while you do this monitor initialization. So next we need to, okay, if we want to copy this admin file, that keyring file to the other machines, you can just say safe deploy admin, and then you can provide those admin node names. So if you just do admin safe 2, safe 3, this will copy to safe 2 and safe 3 machines. Now if you go to safe 2 machine, if you do etc safe directory, you will see the admin has been copied. So once it is done, okay. So once it is done, then if you need a manager generally provides user interface. So it is not a critical stuff, but anyway we can create the manager node on safe 1 machine. So once the manager node is created, then we can create the OSDs. So to create the OSD, this is the syntax: safe deploy OSD create, and then we need to give the disk and the node. Okay, so let's just copy this. So if we just do safe -s now, before we do, we can see we have one manager node and one monitor node is available. So next we will add the OSDs. Remember, we added 3 extra disks on each of the machines. So we will add those disks as OSDs here. So create the OSD first on safe 1 machine. Similarly, we will do the same thing for safe 2 machine, and SEF3 machine. So we have created one OSD in each of these three machines. Totally three OSDs we are going to create. So this is using the first disk on those nodes. Okay, now if you do SEF -S, you must be able to see three OSDs up and running. So let's also add another six OSDs, basically VDC. So you can check here, and if you just do LSBLK, you'll be able to see those extra disks. See, one disk has already been converted into SEF cluster. You will also do it for VDC and VDD. So this Mimic uses BlueStore file system instead of XFS. BlueStore is a new file system that has been created by this Red Hat specifically for SAFE. So here you can see the BlueStore. There you see we have 9 OSDs. So once it is done, then next, we can add the, okay, if you need MDS or RDOS gateway, okay, we can add those, but we don't require it because we are going to focus on this RBD. But anyway, if it is required, you can always create it. Let's actually add one. Let's create one MDS also. The MDS actually provides the safe file system. RBD is block storage, and the MDS provides the safe file system access. And RDOS gateway provides object storage. Now, if you do SEF -S, you'll be able to MDS. Where is our MDS? It's not showing. Let's add the monitor. We will add some three monitors. We have already added one. Let's add SEF2 and SEF3 also as monitors, so that it acts as a HA backup. But how we need to add one by one. Okay. SEF -S. So there you go. We have 3 monitors running. So if we want to add more managers, we can also add more managers by just doing SIF deploy manager, create, and then we can add more managers for for HA configuration. So now let's do safe minus yes. There you can see the standby managers has been added. So finally, if we need the Redis gateway, okay, we can install by just doing safe deploy rgw create, and you can say safe one. This will deploy the Redis gateway. So until now there are no poles created. When you create the Redis gateway, it will be creating some poles. Okay. Now if you do safe minus yes, so here you can see the
So then here we are setting object access as well as block access both, right?
block access, object access, file access, all the three we have enabled here.
In OpenStack case we have done only the block access or BD access.
Generally,
Not the
generally for OpenStack we use block access. For object access, we can use Swift, or we can link Swift to the safe backend. That is also possible. And the file access, the safe file system, it's pretty new. Okay, people still love clusterfs rather than using SafeFS. But SafeFS, maybe in like this year, people might start using SafeFS instead of clusterfs. During last August, when I was training you in Safe, at that time SafeFS was still in experimental stage. Now we need to check the documentation whether it has been recommended for production usage. If it is, then people will start using Safe. So wait for this state to okay. So now you can see there are too few PGs per OSD. So this warning has to be rectified. So it says that the number of PGs that is available is not sufficient. Okay, so it says that few PGs per OSD, it has only 10. Okay, minimum it requires 30. It says so. Number of PGs that we have is only 32. So we need to increase the number of PGs. So let's do safe OSD ls pool detail. Pool, wait, safe OSD hyphen help general egg pool grep detail. Okay, it is pool ls. There you go. So here you can see the number of PG. It is 8 here, 8 here, 8 here, 8 here. Okay, so let's just increase it to 50 to each of these, so that should resolve the problem. We need to use a set command to do that. We need to use wait. I need the syntax. I don't remember it. It is pgp num. Okay, what is the command? I think it is safe osd pool set pgp pgnum 50. Oh, not this. Okay, what is that command? Set pool parameter. Wait, let me just check this command. I forgot the syntax. There's a small change. Here it is. Ceph OSD pool. Oh, pool name we need to specify. Okay. Pool name. Then what is the pool name? This is the pool name. Pool name. Wait. Pool name has to follow the set command. There you go. Okay. Similarly, do the same thing for all the 4 pools. Safe deploy must, set the minimum PGP number by default. What? What is the name? That is the pool, right? Oh, okay. I gave default twice. Okay. Okay. Now we have set the PG and the PGP numbers properly. Now we must get the health OK state. Now let's check. Safe -S. There you go. OK state. Okay. So now the Ceph cluster is in a good shape. Here you can see the Ceph MDS is also running here. So we have 3 OSDs, 1 MDS, 1 manager, 1 monitor running on the Ceph 1 machine. If you check the Ceph 2 machine, PS-EF, grep Ceph, you'll be able to see 1 manager, monitor and 3 OSDs. We are not running like MDS on this node. And finally, we can check on this node. Here also the same state like Ceph 2 machine. So this concludes the deployment of Ceph. So next we need to integrate Ceph with Kubernetes. So before that we will take a snapshot. Then we will continue with the integration. This integration will also be using the role and the cluster role binding and all. So I will explain that next week. This week we will just, I will just like put that entire YAML script directly here. And next week I will be explaining you all the details regarding that YAML file. I will show you that now, but I won't be explaining it. Okay, before that I need to teach you a few more aspects like secrets and config maps, etc., and deployment. All those things I need to teach. So next week, I thought of teaching you this week, but this week the setup itself has taken a lot of time. Next week I will explain those objects, and then I will explain these like YAML files that I will be using to do the safe integration with Kubernetes. Today I just wanted to demonstrate to you that okay, it is possible to integrate safe with Kubernetes. We will try to create a pod, and then we will link the pod with block device on safe RBD, and we will play with it today. So at least we can complete one big case study. Because even during Docker, I remember it was Ram who asked for the safe integration. I told him that we will be doing it during Kubernetes. So that's why I thought of giving this a high priority. Okay, so let's take a snapshot. Now start the VMs. Allow it to initialize. Yes, Sujit. So now we will log in to Kube Master. Check whether all the Kube processes are started. Not yet. There is one question from Sujit. Very good question. In exam, do we need to install the cluster, or it will be already there? The deployment part, it depends on the the environment. Sometimes they might ask you to deploy the cluster. Mostly the cluster will be already deployed, but there is a possibility for asking them, like asking you to create or like deploy the environment. That is also a possibility, because if you check the syllabus, deployment of cluster is also part of the syllabus. So better you practice the deployment also in detail. So if you check the Linux Foundation, there, go to training, certification, Kubernetes administrator. So if you check, okay, where are the exam details? 1.13, 3 hours to complete the task. See, installation, configuration, and validation. So there is a possibility for you to get the question on top of, based on this. So better focus on this also. Well, okay, let's check whether all the processes started. Okay, they're all started. Let's log in as Rajan. There you go. So now, we have the Kubernetes cluster. we have the Ceph cluster. Okay, Ceph cluster is built on 3 machines, Ceph1, Ceph2, Ceph3, and the Kubernetes cluster is built on 3 machines, Kube master, Kube worker 1, and Kube worker 2. Okay, so we have 6 machines totally. Now we need to merge, or we need to integrate the Ceph cluster with the Kubernetes cluster. Okay, so for that we need to use the provisioners. Okay, um, so like this week I will just demonstrate the entire aspect like provisioners and cluster role, all those things. And next week I will be diving deeper into each of these roles. Okay, because we have only another 30 another 30 like minutes we have. So this will be enough to demonstrate the integration, but it won't be enough to dive deeper into the objects. So the deeper exploration we will do it next week. So the first thing, so here by default, the Ceph controller manager doesn't have the RBD package as part of it. Okay, it is not there by default. So so either we need to customize the Ceph controller manager by installing RBD by entering into its pod, or we need to create a provisioner and then for the Ceph, and then we need to integrate that with Kubernetes. So the second approach is what we are going to take because it is very neat. So first let's create one directory Ceph here, cd Ceph. So we need to pull an image. Okay, so there is an RBD provisioner image. It is an external storage plugin for Ceph for Kubernetes. So just to do Docker image pull, and this is the image location, RBD provisioner. Okay, so just download it. So pull this into the Docker image registry, and you need to make sure that this RBD provisioner image matches with our Ceph version. Okay, so before we deploy the Ceph, it is better to check the version that is supported by this image. Okay, since I already know that just yesterday I did this demonstration for another batch, so I know that okay, the versions are matching. But if you are doing it, first you check the version of this RBD provisioner, then you deploy the corresponding Ceph version. So if you do sudo docker image history, and if you grep for Ceph version, you'll be able to find out what happened. Image spelling mistake. You'll be able to see the Ceph version is mimic. Just make sure this version and our cluster version are one and the same. So once it is done, the next is we need to set up the RBD provisioner YAML file. So this is the YAML file that I won't be explaining much this week because it's quite big and it has many objects that I haven't covered yet. Okay, so maybe I can just show you briefly, but not in detail. Next week I will go in detail. So you can see here we have created one cluster role object. And this like cluster role is basically, so this is used for role-based access control. Remember, in case of like OpenStack, we had role assignment. Okay, so like like there we have only a role. Here there are two kinds of roles. One is cluster role, and another one is role. Okay, this is like cluster role is a cluster-wide like effect it has for some objects, and then the role is like it has based on namespace effect. I will explain that next week. And the binding is more like role assignment. Okay, so here we create a service account, and then we link, and then we provide the role-based access control for the service account. Okay, and that service account we link it to the deployment. And here you can see the image RBD provisioner which we are deploying. And this is the provisioner name. So this is what we'll be using in the pod to link our pod with. This will be using it in the physical volume claim object to create the volume on the Ceph cluster. So I will not explain more than this. Okay, it will only confuse you. Just copy and paste as in the mob. Next week we will dive deeper. So this YAML file, we need to just create it. So all the objects that are defined in this YAML file, we need to create it in the kube system namespace. So now if you just do kubectl get pod, you can see it is creating the container. Let's wait. Maybe okay, we can also do hyphen watch. Should, so this will let us know whenever there is a change in the container state. See, now it has changed it to running state. Good. Press Ctrl C, come out. Okay, so once it is done, so the next thing that we need to do is we need to create some secrets. Okay, so the secret, remember in Docker we had secret, even in KVM we had secrets. The secret is a way of storing some sensitive data like username and password in an encoded form, in a base 64 encoded form. Okay, so that's what we are doing it now. So we need to create a secret for our admin key, the Ceph admin key. Okay, so the Ceph admin key, you can get it from the Ceph 1 machine. Since I don't have any Ceph terminal here, I will just do a search from here itself. Ceph root at the rate of Ceph 1, Ceph auth get key client admin. This will give me the admin key. Root 123. There you go. So this is the Ceph admin key. Just save this safely somewhere. We will use this. So now we need to create a secret. So kubectl create secret generic Ceph secret type equal to Kubernetes kubernetes.io. Wait, I don't want to make any spelling mistake. 1 second. Okay, .io. Then next we need to provide the key. So this will be creating. So generally the secret is a key value pair. So the key is the key and value we need to copy from this notepad. This is the admin secret key. Then we need to create it in kube namespace. Okay, so once it is done, next we need to create a pool. Oh, there are a lot of commands. Okay, let me just log into the Ceph 1 machine. SSH root at the rate of Ceph 1. Or wait, I can just do it here, Ceph 1. Okay, so first we need to create a pool. Ceph OSD pool create. I will name the pool as cube. I will give PGP number and PG number as 120. Now we can just watch Ceph -s. Oh, it's already helped. Okay, good. So if you do Ceph OSD pool ls detail, you must be able to see the cube pool created, but still we haven't assigned any application, so there is a possibility of Ceph showing an error, some warning. So better set the application to RBD. So Ceph OSD pool application enable cube RBD. So this is to tell that okay, this pool will be used for the block device storage. Now we need to create now we need to create a new user for the Kubernetes integration. So just say Ceph auth get or create client.kube and provide the authorization, allow read permission, and for OSD allow read write execute on pool cube. Okay, so this we must store it in a file. Okay, so we can either copy and paste it in a file, or we can run the same command without the authorization, and you can put ceph.client.kube.keyring. This will create the file, and then you try to cat this. See the same content. Now we need to copy this to all the nodes. So basically the cube master and the cube worker. So everywhere we need to copy this. So two worker nodes and master node. Wait, before we do this, yeah, is it okay? Let's try. Got copied. Next is, I don't know whether the directory is there in cube worker 1. Let me check. etc sif, do we have it? It's not there. Okay, let's do one thing. First, let's install the sif common package on all the machines. SSH cube worker 2, worker 1. This is 2. Okay, so let's go to multi-exec mode. We need to install sif common package on all the machines. Just check etc sif. Now we have the directory. Good. Now let's go to sif1 machine. So from here we can copy the files now. Okay. Next, let's copy the keyring file to worker node. And also the second worker node. Okay, that's it. And then we need to do some little bit of configuration for the pool. So with respect to the OSB pool, it has something called as hash PS pool. Okay, so this like has to be disabled. Okay, so this is not support this Kubernetes. It uses the RBD driver that comes as part of the Linux kernel. Okay, so that is not up to date. Okay, so it doesn't support the hash PS pool, and also the crush tunables. It doesn't support the optimal crush tunables. We need to set it to legacy. So just say okay. First, disable the hash PS pool option on this pool cube. Set it to false. And next, we need to set the crush tunables. Default is optimal. We need to set it to legacy. Now, just do sif -s and make sure it is in OK state. Just wait for it to become OK. Give it some time. It will become OK. Okay, let it take some time. Anyway, it's a warning only. Okay. So now, once it is done, okay, we need to get the key for the cube user because we need to create a secret for the cube user also. So let's just copy this and put it here. The second key, this is the key of the cube user. Now go back to the master node and create a secret for the cube user. So previously the secret that we created was sef secret. Now we have created sef secret cube. This is the name of the secret. And from return key equal to, we need to give like this key. And we must give the namespace as cube system. What happened? Oh, the servers are still not up or what? Okay, sorry. We need to be as Rajan user. There you go. Now if you do kubectl get secrets, okay, get secrets minus n cubes system. Okay, plenty of things are there. We'll just grep for our safe. There you go. We have these two secrets that we have just created. That's it. The integration is done. Now we will just test it whether it is working. So before we do the testing, let's do SSH, or okay, we just go to here SSH safe1 root 123. So here just do rbd minus p cube ls. We don't have any blocks created in this pool cube1. Okay, so it's empty. Yes, Sujit, any questions?
Yeah, can you explain the command which you use to integration again after this testing, after the integration testing?
Sure. Okay, so the first thing is, so there are some, like there is an object called a storage class. Okay, so the storage class, will be used by the persistent volume claim object to create the block device. So first we need to create a storage class. So create the storage class here, and we need to configure our storage class. So I will explain the content here. So this is the storage class version. You can check the API document for this version. This is the storage class kind, the name fast RBD. Then this is the provisioner that we have created. This like RBD provisioner deployment name we gave, right? The same name you need to give it here. This is the safe monitor IP address and the port number. So if you just go to one of the safe machine, safe one, there if you do yum install NetTools won't be there by default. We do netstat minus tulnp grep mon. Here you can see 6789. So this is the IP. So this is on the SEF1 machine, SEF2 machine, SEF3 machine. And admin ID, the admin username, and admin user's secret key that we have just stored it in here. That key has to be stored. We have stored it in a Kubernetes secret object, right? That object's name and in which namespace it is located. Similarly, the pool to use and the username to use for to access the safe, and that user's secret key object name and where it is, in which namespace it is located, and the image format and layering. So these are all safe details. So just save this, and we can create the storage class. Oh, stupid me! I should have created in the. I'm trying to create this in safe machine. Sorry. We need to do this on Kubernetes master. Can remove this file. There you go. Now if you do kubectl minus n cube system get sc, you'll be able to see the storage class. Fast RBD is the storage class that we created with the provisioner is this one. Now, let's see here. Still, there should not be any blocks. Okay, storage class doesn't create any blocks. Only when you create a volume claim, the blocks will be created. So just say my safe claim 1.yaml. this is a like new object persistent volume claim, and this is the name of the claim. And here you can give the access modes. We are setting it to read write once. Read write once means only one pod will be able to access that RBD block in read write mode. Okay. There is so the SEP supports single user read write, single application read write, or multi application read only. Okay, so both are supported. So if you are using if you want the second option, you can say read only multiple or read only many. Okay, there is one word for this access mode. We can check the API doc. Then here we are requesting for the storage resources. We are requesting for 8 GB. So this will create 8 GB block device on Ceph. And the storage class is fast RBD, which will be linked to the RBD provisioner, which will know how to access the Ceph cluster to create the volume. Just save this. Now we will try to create the volume. Okay, now if you do kubectl get PVC, here you can see the 8 GB capacity volume has been created. This is the volume ID. If you do PV, that is the actual physical volume. Okay, this is bound to this PVC. Now if you go here to the RBD, if you run this RBD ls command, you'll be able to see the Kubernetes PVC, and look at the ID B22597 blah 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 123. See, this is the same ID. Where is that? Oh, that ID is different. Or maybe no, this area and that area is different. Oh, why? Oh, it is something else. Okay, I will find out what is the ID mapping. Okay, but anyway, now we have successfully created the block. The next thing is we need to create a pod and then attach that pod to the volume. Okay, that is what we are going to do next. So let's create a pod. So this is a pod, and we are using a busybox image, and here we have the volumes. So here we can see we are defining a volume, and this volume is attached to this my claim PVC. Okay, so remember that persistent volume claim that we have created, which actually got linked to the backend Ceph storage. Okay, so that storage identifier is the PVC name. So that is linked to this volume object. So this volume object, we are mounting it within the pod under this location, user share busybox. Now let's create the pod. Once the pod is got created, you can just do kubectl get pods. There you see. You can also do watch kubectl describe pod, give the pod name, tail, enter. Here you can see successfully it got scheduled to kube worker 2 machine. Volume is attached to the pod, image is pulled, and then container created and container started. Now let's do one thing. In the Ceph node, just do Ceph df. So you will see this cube pool, and at the moment it has 50 objects and it is using 136 MB. Okay, so now let's try to log into this pod, and we will create more okay, we will try to create more files to access the storage, and this must increase. So let's do that. So let's do kubectl exec -it ceph pod1 --sh. Now if you do df -h, you must be able to see this user share busybox is mounted. Look at the size, 8 GB approximately. This is the Ceph class, that Ceph block device. Now let's go to this directory, user share busybox, and in this directory at the moment we don't have any big files. Let's create the files. I will use dd command to create the files. Input file dev 0, output file, I will say file 1, bs 10 MB count equal to 50. This will create a 500 MB file. We will create some 3 files like this. I know I have like touched many new concepts, so definitely it requires sufficient amount of time to explain. So don't worry, just do the hands-on as I have done it. Okay, I will also give you the mop. Next week we will dive deeper into the Kubernetes objects.
Act- Actually, a pictorial presentation of this integration will helpful for us because
Definitely.
it went over my head.
Okay, yeah, of course, yes, of course, it will happen. So now let's look at the utilization. Previously it was 136 MB, now you can see it is 1.2 GB. So see 316 objects. So this proves that the files that we have created are actually got stored in the Ceph block device. Okay, and then let's do one thing. Let's delete this pod and then we will recreate a new pod with and then we will attach it to the same volume. The files must still be there. Let's do that. Exit. So if you do kubectl delete pod, delete the pod, and I will create a new pod using the same YAML file, which will be getting attached to the same volume. So this will prove that the data that we are storing into the Ceph will live beyond the life of the pod. That is the whole purpose of using a persistent volume, right? Next week, I will give, spend more time by creating diagrams, and I will explain a lot of things, the objects that we have touched. So we will, explore in depth. So even if I try to draw a diagram now, still it will go above your head because I need to explain all the objects that we have touched. The reason why I thought of completing this today is we have installed the Kubernetes cluster, we have installed the Ceph cluster. It's better to show the integration at least. And next week we can dive deeper into how we actually did that. Okay, so now let's try to create the pod and log into the pod. You must be able to see the same files. What? Oh, still the pod is not ready. Okay, so wait for the pod to be ready. Okay, now the pod is ready. Let's log into the pod. df-h user share busybox. Just do ls-l. Here you can see the files are still there. Okay, this proves that everything is fine. Now let's delete all the pod, PVC and PV. Everything will delete and then see what happens. Delete pod, save pod 1. Okay, now let's do kubectl delete PVC, my claim, and also PV. What? PV is not there. Okay, kubectl get PV. Okay, PVs are automatically deleted. Get PVC. PVC is not there. Check the pod. Pod's also not there. Now here you can just do ls. Okay, see when we deleted the PVC there, the block is also gone here in safe. Okay, so I just wanted to revise the concepts once. One second. Let me first upload the mop. Then I will go through the steps. Trying to upload the PDF. One second. So 1 second. I'm just converting it into a PDF. Okay, it's ready. Let me upload it. So there you go. I have uploaded this Kubernetes deployment file. Just open this PDF. We'll actually walk through this once now. Okay. Enable scrolling. Okay. So what we did was we just used 6 machines, 3 machines for Kubernetes and 3 machines for Ceph cluster. So each Ceph cluster had 3 20 GB extra disks. I should have formatted this table. Okay. So next, we prepared the nodes for Kubernetes installation. Basically, we installed a Docker on all the 3 machines. That is kube like master and as well as on worker 1 and worker 2. We set up the Kubernetes repository, and then we installed the kubeadm, Kubernetes CNI, kubelet, and the kubectl version 1.13.1. Then we switched off the swap because Kubernetes doesn't work with swap enabled. Next, we got the Calico YAML files, both the role-based access control YAML file and as well as Calico YAML file. And we found out the IP that is used for the pod network inside the Calico. The same IP we have used it to set up the cluster. So the Kubernetes version you need to say 1.13.1. So once the installation is done, so next you need to create one user with the sudo access. Next we need to copy the Kubernetes admin conf to the .kube directory. Then we need to apply. We need to create the objects for Calico. So using the YAML file that we have downloaded, and then we need to enable this like bash completion. So once it is done, then we can get the token to add the nodes, that is the Kubernetes worker node 1 and as well as worker node 2. So when you add, you must be able to get the node status like this: kube master, worker 1, worker 2, like this. Then we need to do the deployment of Ceph. So this is on 3 nodes: Ceph1, Ceph2, Ceph3. First to disable the firewall and network manager. Then we need to set up the Ceph repo and install the Ceph deploy, and also install the Python setup tools. Okay, only then the Ceph deploy will be able to run successfully. First you create the Ceph configuration file and define the public network inside the by modifying the configuration file that was generated. Then you can install the Ceph using Ceph deploy install command on all the 3 nodes. So you can see the Ceph mimic has been installed. Then you need to set up initialize the monitor node. Okay, so you must be able to see the Ceph1 monitor listed under the services of the status command. Okay, so like next is we need to copy this admin keyring file to the Ceph2 and Ceph3 machine in case if you want to run the Ceph commands there using admin user. And next we created the 9 OSDs. Okay, here you can see the 9 OSDs has been created. So next we created the MDS. Okay, and then we also created some couple of monitors for HA. Then next we created a manager. Okay, so basically there is, I need to put the Ceph minus S after adding the monitors, so that is a typo. 1 second, I will upload the new PDF now. Okay, then we created the manager, 2 managers, Ceph2 and Ceph3, and then we also created an RGW, that is Red House Gateway. Finally, so there was some like warning here, too few PGs. So we just fixed it by increasing the PG and PGP number on all the 4 Red House Gateway pools. Now you can see the health is okay. So next, we can so you can see the various processes that are running here, like MDS and blah blah blah, all those things. Now the Ceph is deployed. With respect to, so now we have deployed Kubernetes and we have deployed Ceph also. Next is we need to integrate. So to do the integration, we need to use this Ceph RBD provisioner. Okay, so for that, so there is an image called as RBD provisioner. This is an external storage plugin which we'll be using to integrate Ceph with, sorry, the Kubernetes with Ceph. So first you need to pull that image and check the version that is using is matching with our Ceph cluster. So it is Mimic. It is also on our Ceph cluster is also Mimic. Next, you create this RBD provisioner. So this YAML file I'm not going to explain now. We will be spending a lot of time next week to explore this. So after we so you just copy as it is into the YAML file, and you can create this objects. So this actually creates the cluster role binding, role binding, service account, and deployment. So these objects takes care of integrating Ceph with Kubernetes. Okay, so you will so like that internal part you will be able to understand next week when I explain this YAML file. So here you can see all those, this RBD provisioner has been deployed. And so once it is done, okay, so then we need to create some couple of secrets. So like one secret is for the Ceph client, the admin user's key. Okay, so that we need to create as a secret. Then next, okay, we need to install the Ceph common package on all the nodes on Kubernetes master, Kubernetes worker node 1 and 2. And then we need to go to the Ceph machine and we need to create a pool for the Kubernetes and enable the application as RBD on that pool. Next, we need to create one Ceph user with read access on the monitor and read write execute access on the pool cube for OSD. Then get the keyring file for that user and copy that keyring file to all the 3 Kubernetes nodes. and also disable the hash pool on that cube pool, and also set the tunables to legacy on the crush map. These two are required because the RBD that is running on the Linux kernel is a older version, so we need to set these to legacy. And once it is done, we need to create a secret for this new user that we have created for the Kubernetes. So we have created that. Okay, we have got that key, and using that key, we have created one Kubernetes secret object. So here you can see we have two secrets. One, so this is for admin user. This is for the kube user. So like now we don't have any like volumes. We can check it by doing rbd -p cube ls. Next, let's create a storage class. So the storage class is where we define the integration aspects. So the monitor location and the safe.
So where we creating these secrets on the chef node or on the kube master node?
These are all on the master node. See, we are using kubectl. kubectl will work only on the master node, not on the safe node.
Yeah.
So here the safe storage class is the one that actually integrates the safe with Kubernetes. So here we need to give the safe our safe cluster monitor details and the admin username and admin user secret and its namespace and the pool name and the username to use and also the user secret and the location of the secret in the namespace and the image featuring. So this layer format 2 and image features layering, these only two like these has to be enabled. And like so remember when we were doing this safe lab, when we try to mount this RBD image into Linux, it was having some issues, so we were disabling the features. If you just replay that video, you will understand why we are having only the layering. But for others who haven't undergone their training for safe, we'll be covering it as part of OpenStack next. So here we are creating the storage class. The storage class is the one that actually does the integration of safe with the Kubernetes. Here you can see all the parameters of our safe cluster. So once we have the storage class, then we can create a claim. The claim will create the volumes on the safe cluster. So here in the claim, you need to give the storage class name. That is so this is where we tell in which safe cluster we want to create the volume. You can have multiple safe clusters and you can integrate multiple safe clusters with your like Kubernetes platform. So but when you create a claim, you need to tell from which cluster you want to get the block storage. And here we are
in storage class configuration, we integrate this cube storage pool with the Kubernetes, right?
Exactly.
Okay. So for every time when we create a volume, so we need to define the which pool
storage class.
We need to define the which storage class it should use.
Yes. Okay, so now we need to give the storage class. So here we are telling that, okay, so please get the persistent volume claim from this storage class we are telling. So it will automatically go and get, create one block in that safe cluster. So once you create it, now you can go ahead and then check the rbd ls -p cube command, and there you must be able to see a block device created on the safe cluster. So next we can create a pod and we can mount that volume into this pod. And once you create the pod, you can log into the pod and you can see that volume is mounted in the directory that we have specified in the mount path inside the pod specification. Now you can go to the safe machine and you can run safe df to see the current utilization. Next, you go to the pod and then create some 3 files, each with 500 GB, 500 MB size. Now again you go to the safe cluster and check for the utilization. You must be able to see there is a high utilization. Then you can delete the pod and you can recreate the pod to check whether the files are still available, because the files are actually not available on the pod. They are available on the safe RBD. So the deletion of pod should not affect those files. So here you can see even after remounting those volumes on a new pod, since the new pod is able to see the files. Okay, this is how we did the integration. Is it clear, Sujit? Okay. Anyone having any questions on this? Amadav, Hamid, Pradeep, Rishi? Please do the hands-on. That is very important. I will also create. I will just convert our like Kubernetes, this VM into an image, and I will share the image name. It will be available under Ratnam Trainers. Okay, you can use this and you can play with it. Okay, fine. So we will stop here, and we will meet next week then to dive deeper into the various objects of Kubernetes.
Thank you, Rajan.
Thank you.